Alright, draft science video. Yeah, I've been wanting to do this for a few days. Anyway, haven't really thought about it too much. Just a couple of concepts. Okay, first concept that, alright, so matter's always moving internally, the atoms. And always, in the real world. And it's doing it as a frequencies, lots of different frequencies of movement. And that theoretically, once it starts moving, it doesn't stop moving. It has to lose the movement to something else that it makes move. It has to dispense of the energy by something else taking the energy. So in its world, there's no friction, there's no losing any of the energy. So if a photon, for example, goes into some matter and it's getting just bouncing around from atom to atom, getting shot here, absorbed there, shot away, absorbed, shot, absorbed, that can be a reality. It can bounce around inside the matter forever, theoretically. Yeah. And the second thing would be this idea that the speed of light, as it goes through glass, can be altered by up to 40%, slowed down by 40%. And what would cause that 40% difference? And so if I combine these two things, I guess I can maybe come up with some sort of answers. But yeah, it's sort of interesting. So anyway, this is how I would look at it, how I would draw it, I suppose. This is my first, I'm just doing this as I think it. So this video is definitely a draft science video. Alright, so you have matter, which doesn't have a straight line like this, to delineate between the matter and the non-matter. I mean, everything's connected to some kind of atmosphere, usually, in most cases, or if there's no atmosphere, there's still the edge of everything has atoms, theoretically, with electrons, theoretically, moving around the nucleus of an atom. So there's the field of electrons that define the perimeter of matter. It's not just matter. And so these atoms are usually in an arrangement, in a solid form anyway, where they're not changing position much, but they are vibrating. They're just constantly, their position slightly changes all the time with at different frequencies of vibration. So there are multiple frequencies that are bouncing the matter. And that theoretically one could argue that they will all, because of the law of thermodynamics, that whatever's going on here will, over time, everything will start to jiggle at that rate, or start to acquire that property. It'll find a balance, so to speak, a routine, you could even argue. So anyway, when light comes in, a photon of light, what happens to it by the time it gets to the out, before it gets through the matter? Well, if it's reflected, what it's theoretically being done is it's being absorbed by an electron, an atom, probably an electron, but regardless, and it's being readmitted as a new photon. And that's why you see color. Color is more likely defined by the character of the electrons, at least what orbit they're in, is going to define the color. So each photon, say I see something that looks brown, again, it's not really brown. It's not a brown electron. It's one of the primary colors, and it's just that as the stream of electrons, which we usually see things as a stream, especially us, because we don't have very low light capable eyes. We don't see one photon. We have to see them as groups of at least 5 or 6 before our brain can acknowledge the existence of something we saw something. So we're going to see color because we're going to see a mixture of electrons. If we just saw 5 or 6, we still couldn't resolve anything. We couldn't tell what it was. we can only tell what it was in the context of millions of photons. We have to see millions of them before we can resolve an image. Something like that. No, a million, I don't know. Thousands anyway. Many thousands. And see it at its accurate color, or its, true, most dense, most saturated, in terms of the color richness. But what's really happening is, as the stream of electrons comes in, something changes in terms of what electron hits, what electron is hit. And so this is how, each compound has its own color. Like when they do spectrology, they burn these compounds and this releases, a color spectrum. And I think the color spectrum is also built into the structure of the atom. So different materials produce a different color because of the structure of the electrons exposed to photons. So depending on how the atom is structured, especially in terms of how the surface is structured, until how the atoms arrange in the material, will dictate what color you'll see the atoms produce. Yeah. So anyway, now as light goes through, it's some percentage, 4% or whatever, I guess up to 16%, gets reflected. And that's a whole nother story about this difference in reflection, in how light's reflected, in that depending on the thickness of the glass, more or less light will be reflected. So from 0 to 16%, depending on the thickness of the glass, which is weird, conceded, but I think it's explained in, by mechanics. I think there are physical mechanics that are dictating that strangeness. So anyway, when light enters, it's not entering, some kind of, and you also have to understand there's literally millions, of atoms between, for every little tiny millimeter of glass, there's, millions of atoms that the light will have to travel within the range of, or through, or be reabsorbed and emitted by. And somehow it has to retain its character getting through in a transparency. So for something transparent, the light goes in and it comes out pretty much unmolested in terms of its the association of the photons and the how they are related to each other. If there was more than one stream of photons coming in, they retain their data. There's little distortion. But anyway, so as they come in, I think what's happening, just give a larger view over here, to create the slowdown, would be that this frequency that this stuff is always moving at will end up moving the photons also. And if the higher frequencies, see, this is an interesting fact, is that there's two kinds of energy here. There's the energy of an actual object moving into a substance, like traveling into it, and this jiggle thing, this, moves one way, and then moves back the other way. That's two movements. It has to be understood too. So it actually does move in a direction, and it moves back to its normal direction, or all the way back to some eccentric direction, and all the way back to the middle again, and back. It's doing maybe even 3 or 4 different movements. There's a lot of movements going on. So for when the photon comes in, it's going to be electromagnetically distorted slightly by this jiggling effect. And so its path would ideally be just straight, and that would be the speed of light. But what's happening is its path is being jiggled by all the movement of the atoms it's passing by or through or interacting with. So it is that interaction that is creating what would the phenomenon of a slowdown. So it's not really slowing down. The light doesn't slow down. That's a wrong way to describe the effect. Now what's really happening is the light is traveling more distance to get from one point to another point because of how much it's being manipulated in attempting to get through the substance. And so it's just traveling more distance, and distance equals time, and therefore there's no way to it obviously will take longer to get through the substance if it's got to travel more distance because of its sideways or non-direct movement. So all the indirect movement created by the noise of the atoms moving is probably creating the extra distance. Now the question is how high a frequency can these atoms jiggle at? And that may be, it may be that they can jiggle very fast, at very high frequencies. So they could do a lot of back and forth kind of movement and very slight movement. It wouldn't take much of a movement left or right from their path, indirect from their path, to create a lot of extra distance if this frequency is very high. So I mean, the frequency could be very slow, low noise, but it could be very fast, which would mean a lot more distance in a lot shorter space. So the frequency of the vibration of these atoms, what frequencies they're vibrating at, will dictate speed also, which, this gets into color shift and a lot of other stuff too, because it's not the photons themselves aren't being color shifted because they're not actually being they're just being altered in their path, not being structurally altered in a sense of being out of phase with each other. So that's another question, is what is the nature of frequency? I mean, is the photon itself a thing of that carries with it its own sine wave of character, or is the photon just is the frequency something within one single photon, or is it a manifestation of the distance between photons and how short the distance is between them? So the size of the photon, so to speak, there would be two variables to consider, would be the size of the photon and the distance between photons. Would be two elements that would dictate something that we might call frequency, in terms of trying to figure out what exactly. So I mean, a question I still have is that, can a single photon carry frequency information? Because it seems it must, just by the math, because they use math, basically frequency equals amplitude equals energy. But I just don't know if that's true for a single photon. Whether they have a fundamental nature besides having a length. So again, there's 2 points to figure out, is whether the photons have a length and whether the distance between them is alterable, like where they can actually have spaces between them. So there's two elements of their character. What are they themselves, and is it just a phenomenon of how they move? So I could argue that all photons are the same, that they're all just a thing. I would say a collection of quanta, but whatever we say, let's say they're just four quanta,
And frequency could just be a manifestation of how many of them, how they're packed. So if you and what kind of distance is between them. So if you pack them with no distance between them, they would just be a chain that would end up being indistinguishable. And so it could be a very long chain, like a radio wave or something, a radio photon. Would be a very long chain of photons, and then the gap would be hard and resolvable. So it could be more about the gap created between them. And likewise, the photon could just be one thing always, and the gap is the only thing that changes. And as the gap gets wider, you get, and they can get dramatically wider, like millions of times wider. So I could make, you can't really make a proportional representation, but it would be, this, like the space between these two lines and the space between these two lines can't even come close to representing how the difference between a radio wave's frequency and a photon of light's frequency. So you're talking about like scales of, between apples and earth kind of comparisons, very huge differences in these distances. And so theoretically a radio wave could just be the same photon just traveling with a very large distance between the sequence of photons. And light could have the photons much closer to each other in terms of the rate at which they flow. So I haven't figured out exactly how that ties into the movement of atoms. So these are the two kinds of movement, two kinds of energy you have. Is the vibration created in matter, where it is although these are probably very centric kind of devices, they're vibrating very eccentrically, like as if they were not round wheels, as if they all had like a dimple in them, and the dimples were hitting each other like gear work. And so as each atom turns, it causes a turn in the other atoms, and that atom turns another atom, and they do that turning to each other constantly. And if they aren't connected to an atmosphere, a surface that they are exposed to, that can bleed out some of that energy, where that movement can get lost when it goes out into the real world again. So in any kind of closed system, once they start a movement, that movement will just keep moving throughout the matter forever, theoretically. And then you have this other kind of movement where the bits are moving actually from one place to another place in this bigger context. But theoretically it's all the same movement. Theoretically we're just talking about the movement of these electrons, which, as I've theorized, are just photons in an arrangement with each other, just traveling together to make an electron. And how they're spinning dictates what kind of speed they have. So like the jiggle, the electron is spinning, creating an internal jiggle. Not unlike this being slowed down in glass effect, an electron can be slowed down or speeded up based on how fast it spins on its some kind of center axis. So anyway, this is where I am currently. So I have to nail this frequency thing down. This one's always bothered me, and I just haven't found the explanation that makes it visualizable as to what function frequency actually has. You know, whether it's just a function of size or whether it's a function of distance. Yeah, which it's technically might be similar things, but they're not in a way. And anyway, so but this all does have to do with what when I come up with some explanation of what hooks these things together and how the hooks can vary in terms of, you know, their length is what we're really, I mean, what hooks, what ties, what obliges photons to tend to come in streams. That's their tendency. They want to do that. It's very difficult to create a single photon event, and it's not even sure that that can be done, only through manipulating a stream in some way, creating some sort of mechanism that breaks a stream rather than one that actually admits a single photon, theoretically. But that gets to the two-slit experiment and all that kind of stuff again too, just because of the strangeness and how the experiment's conducted, the strange rules that don't seem to be modified, where your source of photons is scattered deliberately, and that these distances between the source and the first emitter, which is the first this thing to create a focus, and then you have two slits, and again you have a large distance. So you have large distances between these events, and you're saying, why do you need a large distance if theoretically the only photons that are going to be meaningful are ones doing something somewhat direct? Why would you need large distances? Because that directness isn't going to be changed. No matter how much distance you create, you shouldn't be changing which photons are getting through the device. Distance should be irrelevant to what photons are getting through. So it does give me the impression that some of the photons getting through are photons that are actually ricocheting off the internal device and coming in at very eccentric angles. So some of these photons are really eccentric. So you're almost filtering for the most eccentric photons that you can get out of the device. The greater you make the distance, maintaining some output, the more eccentric, more likely of ricochet photons that you're going to have coming through your device. So you're going to have the most scattered photons. And these are likely photons that have already interacted with materials, become readmitted, and had their character substantially changed by that readmission process. So these are not directly produced bullets. These are bullets, so to speak, that have already been highly manipulated by the device claimed to be producing them. So when they use these stupid metaphors of a machine gun shooting bullets through two slits, that's not what's taking place in the experiment when it's being conducted on these tiny particles. They are not being shot directly through the slits by straight line paths. And that is what's creating the phenomenon of a filtered result, is the fact that they have a device that's filtering the photons in time. I mean, obviously the ones following more distance have gone through more cycles of time. So anyway, that's probably enough for this video. So, response videos, if somebody's interested in the subject, would be neat, but whatever. So the most glaring question I haven't resolved is the nature of frequency. You know, whether it has to do with the gap between incidences of photons, or whether it has whether it is something that is a construction of a photon itself. Yeah. Unresolved for me as of yet. Yeah, I think it's enough.